Hi guys, this is Viha Suhasbhat from SVCE. My USN is 1V22IS059 and today we're going to talk about try and catch and multiple catch clauses in Java. So here's the outline. We're going to see introduction, syntax of class try and catch, handling multiple exceptions using catch clause, order of catch clause, exception hierarchy, best practices for using try and catch, and common mistakes to avoid. So what is catch, a try and catch? So try and catch is a fundamental concept in Java that allows developers to handle exceptions gracefully. It's essential for managing unexpected errors and ensuring the robustness of Java programs. The try catch block in Java is used to handle exceptions and prevents the abnormal termination of the program. The try block includes the code that might generate an exception. The catch block includes the code that is executed when there occurs an exception inside the try block. Here's the syntax for try and catch. Here's an example program where we are using divide by zero. So for each try block, there can be zero or more catch blocks. Multiple catch blocks allows us to handle each exception differently. The argument types of each catch block indicates the type of exception that can be handled by it. Here's an example for multiple catch blocks used in the program. In this example, we have created an integer array named ARR of size 10. Since the array index starts from 0, the last element of the array is at array of 9. Notice the sentence array of 10 equals 11. Here we are trying to assign the value to the index 10. So hence index of bound exception occurs. When the exception occurs in the try block, the exception is thrown to the first catch block. The first catch block does not handle an index out of box exception. So it is passed to the next catch block. The second catch block in the above example is appropriate exception handler because it handles the index out of bounds exception. Hence, it is executed. Next is handling multiple exceptions with multiple catch clauses. So we have order matters. So where the catch blocks are evaluated in order they appear and the first matching block is executed. Specificity, each catch block can handle a specific type of exception, allowing for fine-grained error handling. Clarity, this approach makes the code more readable and facilitates pinpointing the cause of executions. Order of catch clauses. So order of catch clause should be from most specific to least specific to avoid catching exceptions in an unintended block. The order in whatever matches first gets executed. So if the first catch matches the execution, it executes. If it doesn't, the next one is tried and on until one is matched and none or none are. So when catching exceptions, you want to always catch the most specific first and then most generic as runtime exceptions or exception. For instance, imagine you would like to catch a string index out of bounds exception thrown by string character at index method, but your code also could also throw a null pointer exception. So here's a program segment showing the same, where you have different catch blocks and in order so that if the more highest priority error is given in the first catch. So next is exception hierarchy. Understanding the inheritance relationship between exceptions is crucial for effective handling. The class at the top of exception class hierarchy is the throwable class, which is a direct subclass of the object class. The throwable class has two direct subclasses, exception and error. The diagram below shows that standard exception and error classes are defined in Java, organized in Java exceptions hierarchy. So in this table, you can see the throwable class is divided into two, error and exceptions. Error again is of four types: linkage error, assertion error, thread death, virtual machine error. And exception is of five types: input-output exceptions, reflective operation exceptions, runtime exceptions, clone not supported exceptions, and interrupted exceptions. All of these have sub-exceptions or errors in them. Kindly go through the same. Next are the best practices for using try and catch methods. So error logging. First is log exceptions to aid in debugging and troubleshooting. Then clean up code. You use the finally block to release resources and clean up after exception handling. Catch specific exceptions. Prefer handling specific exceptions rather than using the catch-all approach, which makes the program more simpler and specific to your need. Next, there are common mistakes to avoid when using the try and catch. So ignoring exceptions, that is one thing we shouldn't do. It's common pitfall to ignore or suppress exceptions, leading to unexpected program behavior. Next is overcompilating exception handling. So applying overly complex exception handling logic can make the code convolute and challenging to maintain. So, in conclusion, the good practices are avoiding nested try blocks and creating custom exceptions for different error scenarios, and common errors including ignoring exception handling or using generic messages with specific error details. Thank you. Have a great day ahead.